The feedback system API is independently deployable. What that means is that you don't have to have the front end or back end of the core Breeze Home application running or installed in order for you to deploy the feedback system. I assume that you're running in a Linux environment. Right now I'm running a Linux virtual machine in VirtualBox, and the host machine is running Windows 10. So I assume that you have Git installed on your Linux machine. So what you're going to do is run a git clone with the git URL. Now this is actually pointing to a private repository, but for you, you're going to be changing this URL to the actual URL for the feedback system API project. So let's go ahead and change our working directory to the Breeze feedback system. We're going to do an ls just to make sure that we have all the files there. Cool. So I'm running VS Code. You can really use any text editor or IDE just as long as you can recognize TypeScript syntax. So this project is a TypeScript project. So just as long as you can be able to have nice syntax highlighting and all that stuff, you should be fine. Everything else we're going to be doing through the terminal. So let's go ahead and open up that folder now. Okay, so we've opened up the cloned repository here. You can see we have all of our source code files here. So you're going to need a number of dependencies before we can actually run this application. So there are really four things that you need. You need npm, node, TSC, which is the TypeScript compiler, and MongoDB. So MongoDB can be run basically anywhere. Just as long as you can connect to it. So you could have it running on a remote server. Either way, you'll still have to have an instance of MongoDB running. And as far as npm and node and tsc, those are fairly easy to install. So since I'm running on Linux, the command for you would be basically sudo apt-get install npm as well as node.js or node. And you should have those two things installed. So I won't need to run those because I already have those installed. And for the TSC, you're going to basically use npm to install the TypeScript compiler. So you'll do something like npm install-g tsc. What this will do is install TypeScript for you globally. So that means you can use the TypeScript compiler anywhere in your machine. All right. So now that we have those three things installed, we have to worry about MongoDB. So MongoDB should also be installed through npm. It can be installed through npm. You don't need it. You could do npm install and then MongoDB, and that will install MongoDB for you. So if you're running on macOS or Linux or Windows, well, depending on your operating system, there might be different ways to do it. You don't have to use npm, but that's kind of like the easy way to do it if you already have npm installed. So after you have MongoDB installed and all the other dependencies out the way, what you're going to do is run mongod. So what that's going to do is run the Mongo daemon. It'll allow for you to be able to basically connect to it and store documents. Documents are basically kind of like records or rows in an SQL database, but it's for no SQL databases. So you'll be able to store collections, store documents and collections through this MongoD by connecting to it. So when you install MongoDB, you install the client as well as the daemon and a number of other things. And our application is basically going to connect to this Mongo daemon. So you have to make sure that this is running, and you don't really have to pass any arguments here. I think the only requirement is that you have the -data-db directory created. So if you don't have that, you'll basically do a make directory -p/data/db, and this will give you the data directory that you need, that Mongo needs. Right. So now we have basically those four things installed already. Now we have to install the actual dependencies of the project. So the way that we do that is using npm. We're going to do an npm install. So I have to do this because I just cloned the repository, and that basically means that I don't have any of the dependencies installed for this project here. So I have to run this command. The other four commands I didn't have to run because I already have those things installed globally in my machine. So ignore this due to request error during revalidation. You can ignore that. Alright, so we've basically installed our dependencies through package.json using npm. So we could do a tsc and then do an npm start. So tsc basically transpiles your TypeScript to JavaScript, and you'll notice that it created a dist folder. This is where all your transpiled files basically went in the dist folder. So you'll see that they're all .js extensions, where and the source directory, which is which contains the files that you'll be coding in, is TypeScript TS. And I'll show you how that looks like. So it's basically JavaScript with types. Alright. So we also have to do some extra configuration for the Mongo database as well. If you open up the scripts directory, you'll see that there are a number of JavaScript files. So what this does is basically create a collection of documents and basically seeds the database for you, so you have some existing information there, some existing data that you can interact with through the API. So this API user model collection is especially important. So this is going to be run through some sort of Mongo GUI, or you can also run this through the CLI as well, for you to be able to create these documents. So this API user model is important because this allows you to authenticate against the API using these credentials here. So this is actually a encrypted password. So obviously you won't use this to sign in or to authenticate against the API. I'll show you how to do that later. But for now, what we're going to do is open up any Mongo GUI and basically just copy and paste that file. And you're going to do this for all the 4 files that are here. You're going to open up RoboMongo or any other, or Mongo Chef or whatever other GUI that you use. You can also run it through the CLI, as I said before, but it's a lot easier to just do it through the GUI. So if I run this using the well, I'm in the Score database, so here you'll see some collections already there, but that's because I ran this command already. That's because I ran this JavaScript already. So when I do this, it'll insert basically this object that you see here. So you're going to do that for all the objects here, and you're basically going to have 4 collections. So you see more here, but that's simply because I created some objects before. And you notice that you'll notice that my RoboMongo was basically running on Windows 10 if you looked at the title bar. But that's because I've mapped ports between the virtual machine that I'm running to my host machine, so that I can connect using the tools I have on my host machine to the running Mongo D instance in the virtual machine. But you don't have to do that. You can simply install RoboMongo on your VM or in your Linux machine, and it should work just fine. Another tool that I would highly recommend is for you to have Postman. So Postman allows you to do some interesting stuff, like posting to the auth token API endpoint to authenticate against the API. So using the create API users file there, we were able to create a default API user. So using these credentials, you basically do a post to this endpoint, and the body is a raw JSON format, and you're able to pass these credentials, and this is going to be a surefire way to make sure that you have the correct credentials for you to authenticate and use the API. So in order for you to get this collection in Postman, if you're familiar with this at all, you can do an import and basically import the JSON file that is in the docs folder, and you'll see there's only one JSON file there, which is called feedbacksys.postmancollection.json. You'll import this file through Postman, and you'll basically get exactly what you see here, which is this feedback system collection with all these, different requests, and you can see the body of the request to see what exactly is there. Okay, so that's all great and dandy, but we haven't actually run the application yet. So how do we do that? Now that we have our Mongo database basically seeded already with data, we just need one last thing. So we're gonna write a configuration file for our API. So the way that we do that is basically creating a file on the project root called config.json, and you're gonna copy these files here. this code here. So there are three options that you can specify in the configuration file. It's database connection, port, and secret. So database connection is a MongoDB connection string that allows you to connect to your running Mongo instance in order for you to basically store data through the API. So since I'm running MongoDB locally and not in a remote server for a host, I can literally just put localhost. And then for port, the default port for Mongo is 27017. And then for the database name, I'm going to use Score. This is arbitrary, however. And port is the port that you're running the application on, the API. And secret is some arbitrary string as well. This is used for authentication. Alright, so now we have everything set up. So we can actually do npm start right now, make sure every time you make changes to the source code that you do TSC first to transpile your TypeScript to JavaScript. And then you can run an npm start. An easy way for you to avoid running TSC every time you want to run npm start is for you to run TSC and watch mode. So I'll actually create a new terminal for that. So I can do TSC and then do -w, and this will basically watch for changes. So in my other terminal I can go back, and then basically every time I make changes to the source code it'll automatically transpile, and I can just run an npm start without having to run TSC. Now the tricky part of this is that it doesn't actually compile your code. It says compilation complete, but a lot of times I've had to do TSC and TSCW to make sure that it compiles my code first, and then it runs TSC in watch mode. So I would just double check and make sure of that. So I'm gonna delete this terminal tab here. So we've already transpiled our code. We didn't need to run TSC again, but just for me to show you how that works, we can move on and do npm start. So you'll see that it said connecting to database, app listening on port 7000. So we know that since we didn't get any errors, we know everything is running correctly. Now, just to be 100% sure, what we can do is open up an instance of Chrome, and again I'm on my Windows machine now, but that's because I've mapped my ports to my local host, my host machine. So you're going to go to port 7000 or whatever port you specified. For me it's 7000, and you're going to do /API-docs, and that's going to bring you to the Swagger UI that basically gives you API documentation. So we know everything works. So we're going to go ahead and exit out of that. In order for you to hit any of the API endpoints, you need to request an access token from the API. So this uses authentication. So the way that you do that is basically you hit this auth token API endpoint as I showed you before, and you're going to have these credentials here. So if you seeded the data correctly, using these credentials should simply work. So I'm going to do a send, and you'll see that we got the token here, which is a long string. So I can set this as a token in my environment here. So I created an environment. You'd have to create one in Postman if you're planning to do testing through Postman, or you could simply just copy this into the headers of all these requests, but I like to create an environment so that I don't have to do that. And then we have an expiry. So this token basically lasts for 24 hours, and I can basically use it across all the API endpoints. So if we look at one example, you can see that we have the token header here in this get user behavior request, and then it uses the token that I just set. So you'll see that when that pop-up comes up, you'll see that that's that long string that we just set. And you'll see that there's some logging that's being done by Express. You'll see that there's some gets that we did and posts that we did, and I'll show you the status codes and all that. And basically when you're done running the application, you'll do a Control-C, which will end that running instance. And that's basically it for that. So if you want to make any changes to the code, this is the controllers package that basically has all of the routing stuff, models, which are the schemas, the domain objects, and then services are containing just business logic here. And app.ts is the main entry point. And for any further documentation, you can actually refer to the README file here in Markdown, which has basically everything that I've said here throughout this video.
I want to show you how to import the OSM data to database. In order to create the neighborhood data and to initialize the score data. First, we can search the OSM in Google and then click the first link. And this is the website of OpenStreetMap, and click export. And then select the metro extracts and search Miami here. Yes, we can download the OSM XML file here from this link. And after you downloaded the OSM data, you can put it into the root folder of the Django of our backend folder. And then you can see in this feed OSM neighborhoods.python, in this file you can see the file name here, and you change the name to make them the same, and then you can run and then in terminal you run this first, and then run the Python 3 and feed OSM and run this. After you run this, you will import all the OSM data to Postgres database. And after you finish to import the OSM data to Postgres database, so you can import the score data from Postgres database to MongoDB. So you just run the Python 3 feed MongoDB, and then you can import all the score data to the Mongo database. It really takes a few hours if you have a lot of data to import. Thank you.